So we're going to solve problem number 4. A half-bridge inverter has capacitive elements each of 100 microfarad and a 50 volt battery. The inverter. The inverter frequency is 1 kilohertz and the load resistance is 5 ohms. Sketch the scale the load current waveform assuming ideal switches and asymmetrical waveform. So first we need to write the given. So C, or the capacitive, is equals to 100 microfarad. So we need to convert into pure farad. So 100 times 10 to the power of negative 6. And frequency of 1 kilohertz. So we need to convert it into pure hertz. 1 times 10 to the power of 3 hertz. And for our volts is 50 volts from our battery. And resistance is 5 ohms. So first we need to solve for the time and for the IR, over the current RMS. So first we need to time over frequency, so we can get the 1 milliseconds. So for the time, CR is equals to 100 for the farad, for the capacitive, sorry. So 100 times 10 to the power of negative 6 farad times the resistance, so we can get the 0.5 meter per second, milliseconds. For IRMS, for the current, so we need to VB, for V is equal for battery and R for the ohms. So 50 volts over 5 ohms, so we get the 10 amps. Since we got the corresponding value, so we can now sketch the waveforms. So we got the 10 amps. So from 10 amps goes to here for the 0.5 milliseconds and go under to the negative 10 amps. So ito 1 milliseconds. So on and so forth.